let's work some practice problems where we apply the sum of angles and the types of triangles that we learned in the previous two videos. So I'm going to ask that you draw with me and label with me and write your stuff down so that you can get used to it. Now remember that the HiSET and the GED is all word problems. So we're going to do these real basic ones, but you've got to be prepared to take this to a word problem and work it in a word problem. Now there's lots of good practice out there. Some of the books that I recommend are Number Power Geometry. You can order this on Amazon. It's got lots of great, very basic practice, and then it gives you more complicated practice and word problem practice. Okay, so in this problem, I want to label all the interior angle measurements. I need to decide if it's an equilateral, isosceles, or scalene. And I also want to identify if it's a right triangle. So we've got several things to do. So the first thing I want us to do is to identify the type of triangle. So I'm just going to write type kind of off to the side. So your choices are equilateral. And remember, I did a video on that. You can go watch it. Equilateral, isosceles. Get used to saying that word. It's a weird word. Scalene. And we also need to know if it's a right triangle. And then we need to be able to identify the interior angles. Okay, so I'm looking at this. I've got the sides are all measured, 8, 8, 8. What kind of triangle has all sides that are the same? Well, that's an equilateral. So you're supposed to know from your previous video, if it's equilateral, all sides are equal, but what also do you know about the angles? That they are also equal. In fact, they're all equal to what? 60 degrees. So we're going to write 60 degrees inside our triangle. All right, that's all we had to do. We need to know the type, we need to know if it's a right, and we need to put the measurement on the inside. Okay, so let's do another one. So let's do one that's kind of pointed like this. You've got 6. I'm not going to put my units because it messes it's hard for me to write it in this picture. My pen is kind of thick. So that's 6 centimeters, 6 centimeters, and 38 degrees. Okay, so first I need to know the type. Tell me the type of triangle. If you know that this side and this side is equal, you cannot make a determination about this side because I didn't tell you anything. You cannot assume here. So what are we going to choose? Equilateral, isosceles, scalene, or right? And sometimes it could be right and something else as well. And so you should have chosen isosceles because isosceles has 2 equal sides and therefore it has 2 equal angles. All right, so how do I find these 2 missing angles? Well, I know the sum of all angles in a triangle adds up to be 180. Well, that's good, but I've got 2 missing angles. But what do you know about these 2 angles? You know that this side and this side is equal, so that you know that this angle and then this angle would also be equal. Okay, that's that opposite angle, opposite side association that you know. So how do we approach this problem? Well, we know that if we took 38 away from 180, so 180 minus 38, that would give me how much these 2 are together, right? So just use your calculator if you want to. And you get your 142. Now, that's for those 2 together, but what do you know about those 2 angles? They're both equal. So how are you going to find each one individually? You're going to take 142 and divide it by 2. So 142 divided by 2 gives you 71. So each one of these angles is 71 degrees. So it's an isosceles and each one is 71. All right, let's do another one. So you've got this triangle right here. And these are your measurements. Now, you've got this marking. What does that mean when you have that marking? That means that it is a right triangle. So we know it's a right triangle. Okay, But that didn't tell me if it was equilateral, isosceles, or scalene. So if it's a right triangle, it's what measurement? 90 degrees. So you got 90 and 34. Could it be an equilateral? No. Could it be an isosceles? No, because you have to have two angles the same to be an isosceles, two sides and two angles. So therefore, that makes this a scalene. So that means it's going to have three different measurements for the angles and three different lengths for the sides. Now, how do we find the answer for our missing angle over here? You want to add your 90 plus 34 back together. And so you get 124, right? And then you want to take your 180 minus 124, and you get 56. So you got 56 degrees for this missing angle. So there are some examples of how to work some basic problems. Now, let's do just a couple more that are a little bit different. They're not any harder, they're just a little different. If you have 17, they're giving this as miles, and 23 miles, and 48 degrees, and 48 degrees, and they want the missing side. They're going backwards now, you know, in math, forwards, backwards, forwards, backwards. So we want to only find the missing length, but see, you kind of need to know your types of triangles to be able to apply your knowledge to find your missing length. So if you know that this is 17 and this is 23 and this is 48, that doesn't seem like you've got enough information, does it, to tell you what that missing side is? But really you do. You have to use your opposite angle knowledge. So put your pencil on the 48 up here and shoot your bottle rocket, and you get 17, right? So common sense would tell you that if you have another angle that's the exact same measurement, then the opposite side to that same measurement would be the same length of the side. So when you use your little bottle rocket thing from that one, then if that opposite is 17, then what's that going to be? 17. So your missing angle is 17 miles. Okay, now let's look at this one. This one is a right angle. I didn't draw it very well there. And you've got 45 degrees and 45 degrees. And I need to know this. Okay, I have 10 feet right there. Okay, now, again, I have two angles that are the same measurement and one angle that's not. What kind of triangle is that? That would be isosceles, yes? Because if I have two equal angles, I should have two equal sides, just like this one, right? But you have to use your opposite angle knowledge to do this. So put your pencil on this top 45, shoot your little bottle rocket over, and it hits 10 feet. So the angle opposite to a 45 degrees is 10 feet. So the measurement of the side opposite to the 45 degrees is 10 feet. So the side opposite to this 45 is also going to be 10 feet. Yes, got it. All right, one more. If you've got, notice they turn these triangles all kinds of different ways so that it doesn't look familiar to you. And that's one of the challenges of these shapes and stuff, is when they twist them all around, you've got to be able to kind of manipulate them in your mind and follow along. So here we go. We've got 60, 60. What are you thinking when you hear 60 degrees for the angles of a triangle? Hopefully, look at your list up here. You are thinking equilateral, all right? Because all equilateral angles, triangles have interior angles of 60 degrees. So if I'm looking, well, actually I didn't tell you that, but we're looking for the length of this side, right? So if we know it's 60, 60, we know this is going to be 60. And we know that an equilateral triangle has three equal angles, but also three equal sides. So that's 39 meters for that one.